Example number 1. Compute the horizontal displacement of point F and assume EI to be constant. So parts challenge in frame is to be able to acknowledge or identify the letters to which letters be placed first before the others. So in writing letters, it's actually just the same with the beam. It's just that the procedure would be in clockwise manner from left and clockwise. So let's start. And also with every change of loading and with every change of member. So as you can see, we have 3 members. So all the corners of the members will be labeled with letters. And also for changing of loads and at the point where the flexion or displacement is being asked. So those are the letters that we're going to place. So here we have point A here. Then this one is point B, since this is the beginning of the distribution. And then this is point C because this is the corner or the end of the member. And here horizontal 3 meters, so there is no change of loading except at the end of the distribution. At the same time, this is at the corner, so that ends the member also. Then downward we have point E, and lastly we have point F. So there, we are going to find the displacement of point F. So since this is Castigliano second theorem, then we're expecting a horizontal displacement now at point F. So this is our point F. Then I'd like to have a direction to be in that manner. Okay, so this time we are now ready to solve for the reactions or place the reactions. We have here, you have RA, A vertical, and I'll be placing here A horizontal. The reason, because the loads are applied to the right, so it's better to have that counter. And then at point F there is a roller, so there would be a force vertical. Okay, so these are the reactions that we need to solve. So this frame is a determinate frame. So later sa indeterminate frames, it has already been discussed in your structural theory 1. And then let us just proceed here. Let's get the resultant of this 30 kilonewtons. So the distribution is horizontal, so the resultant would also be horizontal, and it is the product of 30 times 4. This is 150, 120. And then for this 20 kilonewtons, the distribution is 20 kilonewtons. The resultant is 20 times 30, so this is 60. Also, we have an inclined force that we need to get its component. So let's get its component. We have here 90 sine of 30, and we have this downward to be 90 cosine of 30. Okay, so in this case, let's solve for the value of the reaction. So let's have the summation of moment about point F equal to 0. So point F, moment at point F, point A will also pass through point F. Horizontal A will pass through point F. So only A vertical, so clockwise positive, counterclockwise negative. And it's going to be A vertical times 30, and then you have plus plus this 120. So that 120 to be multiplied by 1/2 of 4 is 2, then plus 1, so that's 3. And then you have minus 60 times 1/2 of 3, 1.5. Then we have plus 90 sine of 30 times 3.5. And that's equal to 0. So there are 4 forces. 1, 2, 3, 4 terms. Okay, that's all for our AV. And our AV here is equal to negative, now let's just place it here first. This is negative 360, then negative plus 60 times 1.5, this is 90, and then minus, that's 90 sine of 30, 45 times 3.5, 157.5. 157.5 divided by 30. And there. So our AV is equal to 360. No, this 360 should be negative. There. And then that's negative 360 plus 90 minus 157.5 divided by 30. That's 142.5. So we have negative 142.5 kilonewtons. It says here negative because our assumption is wrong. So 142.5 kilonewtons, and it should be a downward AV. Okay, proceed. Let's have summation of moment at point A, just to check whether we got it correctly or not. Summation of moment at point A equal to 0, clockwise positive, counterclockwise negative. So you have negative FV times 3, and then plus 120 times 1/2 of 4 is 2 plus 1, that's 3, then plus 60 times 1.5, and then plus the 90 cosine of 30 times 3, and let's move it here, and plus 90 sine of 30 times 3 equal to 0. So FV now is for FV, this is after you transfer, you have everything here divided by 3. It's going to be all positive, so this is 360 plus 90, then plus 90 cosine of 30 times 3. This is 233.827 plus 90 sine of 30 times 3. No, this is not 3 but 3.5, kaning 90 sine. .5, so 157.5. So our FV is 360 plus 90 plus 233.827 plus 157.5. So divided by 30. And that's equal to 280.442 kilonewtons. And we got it a positive value. Okay, so let's check whether we got it correctly. Summation of forces vertical equal to 0. You have AV downward, then minus 60 minus 90 cosine of 30, and that's plus 280.442 equal to 0. So this is 142.5 minus 60 minus 90. So how much is 90? So 90 cosine of 30. 942. 77.942 plus 280.442 equal to 0. So let's check whether we got it correctly. Negative 142.5 minus 60 minus 77.942 minus 280.442. No, not minus, plus 280.442. 280.442. Okay, so we have validated that that's 0, so we got it correctly. And also do not forget that we have to get the summation of forces horizontal equal to 0. You have AH negative plus P plus 120 plus 90 sine of 30 equal to 0. So your AH is now 120 plus 45 plus P. So this is 165 plus P. Okay, that is your reactions. AH, A vertical, and FV. Okay, so the next thing that we're going to do is consider every segment. So let's start with segment AA. So, segment AB. So for segment AB, all we have to do is cut here and consider the lower portion because that's a simpler figure. So we have here, and then also do not forget that you have a vertical here, and then your AH, and you have this X, and you have moment. So what direction? So remember how to create a moment. So if this is our frame and mo na siya nga member, then kana sad siya mo na nga member, kana siya nga member. Okay, so since we're considering the lower portion of the member, so therefore we're going to consider this direction. So this is going to be counterclockwise. Okay, get the equation. Summation of moment about point of cutting, well, that one equal to 0, and you have there clockwise positive, counterclockwise negative. So you have negative M plus AH times X, and as you can see, AV will only pass through the point since AV is an axial force to that member. So that's equal to 0 now. So therefore, moment is equal to AH times X, where AH is equal to 165 plus P times X. So moment now equation is 165x plus px. And we have to get the partial derivative since this is Castigliano's second theorem. So it's going to be x. So therefore, the product is equal to 165x plus px times x. Then we're going to set this p equal to 0. And now this is the partial derivative and the moment. 165x times x. That is your segment AB. Let's proceed to the next segment. So we will be cutting here and consider the lower portion, segment BC. So here, let's have segment BC. And for segment BC, we have this portion, and then also we can copy that, there, and then do not forget that this is now the cutting, and this is 1 meter here from A to B, and then at the point of cutting here there is moment and the same direction since we're considering the lower portion. And the distance from the point of cutting towards B, this is x. And remember that this is 30 kilonewtons per meter. Therefore, the resultant is no longer 120 but rather 30x. And also, you have a vertical here and a horizontal. So in this case, let's move it here. Okay, let's now get the moment equation. Summation of moment at the point of cutting equal to 0. We have clockwise positive, counterclockwise negative. So counterclockwise negative m and minus 30x times 1/2 of x, and then plus ah times x plus 1 equal to 0. So transposing m to the other side, it will become positive. So you will have ah times x plus 1 minus 15x squared. And also ah is 165 plus p. You multiply it with x plus 1 minus 15x squared. So m now is 165 x plus 1 plus p times x plus 1 minus 15x squared. No? So we got it correctly, right? And then let's get the partial derivative of m with respect to p. So temporarily, mahimo siyang 0 and this one. So therefore, you will have x plus 1 as the partial derivative. So we are going to get now the product of the two. So it's now 165 x plus 1 plus p times x plus 1 minus 15x squared times x plus 1. And then here, we are going to set the value of p equal to 0 completely. So therefore, the partial derivative would now become the product of the m and the partial derivative would now be 165 x plus 1 minus 15 x squared times x plus 1. So that is your segment BC. So let us continue with CD. So for segment CD, we will be cutting through here, and instead of considering the left side, I'd like to consider the right side. Okay, so let's prepare a segment CD. So this is for segment CD, and I have already prepared that. At the point of cutting, you will have their moment in the direction. Okay, so here, since we're considering the right side, then we will be using that right side. And then here, it's going to be clockwise. And from the point of cutting towards point D, the distance now is x. And then here, this remains 1.5 meters. And this is 3.5 meters. Also, you have the reaction here, F vertical, which is 280.442. And then you have here the 90 sine of 30, the 90 sine of 30 is 45. Then we also have the 90 cosine. So 90 cosine of 30, 77.942. 77.942. Okay, and then we have now a distribution. This time, this is no longer equal to 60 or 20 times 6, but rather this is 20 times x. So get now the moment equation at the point of cutting. Summation moment at the point of cutting equal to 0. It's going to be now clockwise positive, counterclockwise negative. You have m as clockwise, minus 20, plus rather. So plus 20x times 1/2 of x. And then let's consider the 45. 45 will rotate in a counterclockwise, so that's negative 45 times the moment arm is 1.5. And then for the 77, it's going to create a clockwise direction. So 77.942 times the moment arm is x. And then minus FV. Since the rotation of FV is counterclockwise about point of cutting, and the moment arm is x, equal to 0. Oh, do not forget that we have also this point P here. I almost forgot. So you have point P to be in direction counterclockwise. So that's P times 1.5 plus 3.5. It's 5. And that's equal to 0. Okay, so let us now substitute the values and transpose all the values to the other side except for the m. So it's going to be m equal to minus 20 times x times 1/2 of x. This is 10x squared. Then plus 45 times 1.5, this is 67.5, and then minus 77.942x, then minus FV. FV is 280.442, 280.442x, then minus 5p. Oh, I almost forgot, this must be plus and also that. So this is negative, this is positive, this is now negative, this is now positive, and this is now positive. Okay, so simplifying, we now have m equal to negative 10x squared, then plus 67.5, and then plus, let's combine the 77 and 280, 280.442, 280.442 minus 77.942, 202.5. So that's 202.5x, then plus 5p. So in this case, it's already simplified. Let's get now the partial derivative of m with respect to p. So setting all the values except p to 0. So this is partially 0, and the value here is 5. So therefore, the product of the two becomes negative 10x squared plus 67.5 plus 202.5x, then plus 5p, multiply it with 5. So the partial derivative and the product of m is now equal to, set the p value equal to 0. So it's going to be negative 10x squared plus 67.5 plus 202.5x and times 5. So it's all up to you if you're going to distribute that 5 to the other side. Anyway, I mean to the other parentheses. Anyway, it's going to be just the same. So just leave it just like that. Okay, so we're through with segment CD. Let's proceed to our next segment. So the next segment is DE. So I'll be cutting here and consider the lower portion. That's DE. So let's just borrow this. Let's borrow that. And then this is now for segment DE. So for segment DE, we have here, I'll just place now the values of the forces. So by the way, this is point F, and at point F there is 280.442, and there is also a P force. Then at point E here, which is 3.5 meters, there is a 45, and here this is 77.942, 77.942. So the distance from the point of cutting towards point E, so this is point E, and this is the point of cutting towards point E. This distance is x. Now we have moment. So what is the direction? So the direction is, since we're considering the lower portion, then here, that's the direction. That's clockwise. So that would be clockwise M. So in this case, we are now ready to get the moment equation. That would be summation of moment at the point of cutting here, and that's equal to 0, clockwise positive, counterclockwise negative. You have M as positive minus 45 times X, and then this will not cause any moment because it will just pass through at the point of cutting. Also this one, only this and this P. So it's going to be negative P times X plus 3.5 equal to 0. And then simplifying, you will have 45x plus P times X plus 3.5. And then getting the partial derivative of M with respect to P, we are going to set this temporarily to 0, and it's going to be X plus 3. And the product of the two becomes 45x plus P times X plus 3 times X plus 3. So setting the value to P to 0, so the final product of the two is 45x times X plus 3. That is for the segment DE. So let us continue with the last segment. So we are going to cut this through and consider the lower portion. So let's borrow this. Let's copy that. Borrow lang. Then this is for segment EF. So for segment EF, we have this segment, and then this is F. Then we have 280.442. Also, do not forget that there is a horizontal P force, and at the point of cutting here, the distance is X from point F. Then you also have a moment M, and the direction would still be the same from the previous, this one. Okay, so let's have summation of moment at the point of cutting equal to 0. This will not cause any moment as this one goes to point of cutting. So therefore, you have M clockwise and then minus P times X equal to 0. So M now is equal to Px, and the partial derivative of M with respect to P is X, and the product of the two is now Px and X. Then setting the Px equal to 0. So therefore, the final product would be the partial derivative of M with respect to P. That's 0. So we're now ready to get the integral and the deflection. Remember that we are going to find the deflection at, or displacement at point F, and we assume that the direction would be to the right. So all we have to do now is get the 1 over EI of all the integral from A to F. So I'll just paste here something that I prepared for, or I prepared already. This one. This is just my guide for the limits, since this is for the integral of the product of M with the partial derivative of m with respect to p dx from AB. Then the length of AB is 1 meter, so this is 0 to 1. And then we're gonna copy this one and plus the next thing here is for BC. So BC, the distance from B to C is 0 to 4 meters. So 0 to 4 meters. And then plus the next integral this is for C to D. So this is C to D, and then the limit now changed. So C to D, you have 3 meters. So therefore 0 to 3. Next, from D to E. So there we have D to E, and the limit is from 0 to 1.5. And for the last one, so you plus or you add that, and for the last one it's for E to F. So this is E to F, and the length from E to F is 3.5. So that's 0 to 3.5. Okay, so what we are going to do now is get the integral. So this is the 1 over EI times the integral from 0 to 1. So let's copy. The first integral is AB. AB, this one, AB. So let's copy that and paste it here. So this is AB dx. Next, plus the next integral is from 0 to 4. This is BC. So BC here. This is for BC. And here, this is BC. So dx, then plus the integral from 0 to 3 CD. So CD, where is CD? This one. Copy this. And this is for CD dx. Then for the next integral, plus from 0 to 1.5. So it's from D to E. So D to E, this one. And here. Then this is dx. Then plus the integral from 0 to 3.5 e to f. E to f is 0 dx. Okay, so let's continue. 1 over EI times, let's start with the first one. The integral of 165 x times x from 0 to 1. That's 55. Next, here. This is the integral of 165 times x plus 1 minus 15 x squared. Oops, what happened? Balik ko na to. The integral of 165 times x plus 1 minus 15 x squared times x plus 1. The limit is from 0 to 4. 5540. That's 5540. Next, the integral of negative 10 x squared plus 67.5 plus 202.5x, then times 5, limit from 0 to 3. So that's 5118.75. So that's plus 5118.75 plus the last one here, the integral of 45x times x plus so is this x plus 3? We just check on this one. No, this is not x plus 3 but 3.5. So this is 3.5, and here this is 3.5, and this one and this one. So we're gonna change it here because this is 3.5. There, 3.5. So the limit is from 0 to 1.5. 227.8125. So the integral of f, which we assume to be to the right, is equal to 55 plus 5540 plus 5118.75 plus 227.8125. That's 1 over EI times 10941.5625. The unit is kilonewtons cubic meter. And this is our final answer. So this is displacement, no, horizontal. Horizontal displacement of point